traditions of the French, because the French are great mathematicians. Right? They have produced many Fields Medal winners. If you look at the history of mathematics, the proportion of those top mathematicians who are French is significant. Right? It's right up there with the well, let's say if you take 20th century, because of America's dominance and because its salaries, it came out of the Second World War with about 50-60% of world product, absolutely dominant, and high standard of living, and it just attracted all the world's best brains, including Europe's Jews, and the Ashkenazi Jews are the brightest people on the planet, right? So America benefited enormously then from its Jews until they took over and now dictate America's foreign policy in the Middle East. Do you know America pays somewhere between 3 to 10, depending on how you define it, $1 billion a year to Israel or Egypt to not go to war with Israel? Where did that come from? America's Jews. So I'll make a whole tape about the abuse of American Jews. They've just sold the American public down the river. I'm sharply critical about this. Anyway, that's another whole other video, different topic. Okay. Alright, so what we're going to do now is give an example for didactic purposes of a Turing machine at work. So you get a feel for what a Turing machine can do. And once people caught on to the idea of what Turing machines could do, that they started to think, hey, maybe we could actually build a real machine, because this is a pad and pencil. This is a paper machine, right? It's a concept. It's a mathematical concept in a sense. So people were inspired by the idea of the Turing machine and began to think of actually engineering one, building it. Just a minute, the air conditioning is not working. I'm getting hot. Just a minute. Maybe the thermostat switched it off. Okay, so we'll have an input string, and it will be of the form a random binary string called W, and maybe I should switch on the light as well. Just a minute, if I can find my hat. I went to bed too late last night and got up too late. I'm running out of daylight. Right. So the task of this machine, this Turing machine that we're going to describe in reasonable detail so you get a feel for what a Turing machine can do, the input string will be of the form a random binary string. So W here belongs to the star of this set, 0 and 1. So W is just a random binary string of noughts and ones. Okay? And in the middle you have the hash sign. Remember, hash is just sort of looks like the hash marks on a chopping block. When you hash up meat, chop, 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 chop. So it's called hash. I've said this before, right? So your input string is of the following form: arbitrary binary string, hash, and a repeat of the same binary string as here. So W hash W. And the set of all those strings, that's a language, right? So you're talking about language B. And the task of the machine, the Turing machine, M1, M for machine, our first example, okay, chapter 3, is to see if a particular string belongs to this language. That's the task. So in other words, effectively, what we have to do is we have to look at this string, this W, and see if it's the same as this one, or well, to see if this one's the same as the first one, or equivalently, are these two strings here, either side of the hash mark, the hash symbol, are they the same? That's the task. Okay. And if this machine, this Turing machine, detects that these two are the same, it will go into the accept state and stop. Okay? And if these two are not the same, it will go into the reject state and stop. Okay? Alright, so now imagine that you are this machine, okay, and you've got, let's say, a mile long. Miles. I think America, it may be the only, or at least just a small handful, maybe the only, or certainly the only major country on the planet that still uses the old, I don't know what it's called anymore, but doesn't use the metric system. It still uses miles and Fahrenheit, and the rest of the world uses the metric system, kilograms, and centigrade, and so on. But it'll cost billions of dollars for the Americans to make the conversion, and they will eventually, because their proportion of world trade keeps getting smaller and smaller and smaller, as Europe now is the world's biggest trader, and with Asia growing furiously now, so the proportion of America's influence, economic influence on the world is continuing to diminish, and so eventually the big world will just force America to convert to the metric system. But it hasn't happened yet, because in the past America was so dominant, he could just snub the rest of the world. He could just give the finger to the rest of the world. But soon it'll be the other way around. And so even Americans will no longer be talking about a mile-long input. Anyway, so imagine your input tape on this TM it's a mile long, and it contains millions of characters. So this string here is huge, very, very long, and you have to find whether the string here is identical to the string here either side of the hash sign. Okay, and that's the task. Now you can't remember if you're the human being trying to imagine yourself behaving like a Turing machine. This string is too long to remember it yourself. Okay, so but you can move back and forth on the string on the tape, okay, and make marks. You can change the symbols on or in the squares of the tape, the Turing machine tape. You can do that. Now, one strategy, if you think about it, is start at the first symbol of your W here, and remember what it is. Is it a 0 or a 1? And then move until you get to the first symbol after the hash. So just keep moving until you get to the hash, and then look at the next symbol of here, and ask, is it the same? If it is, fine. And then you've looked at the first one of this one and the first one of that one, and once you've looked at them, and you don't want to repeat, you don't want to look at those two again. You've already checked that they're the same. Oh, well, by the way, if they're not the same, immediately reject. Go into a reject state and stop. Okay, but assuming they are the same, then cross them out. So the first symbol of your W here and the first symbol of this W here, cross it out. Overwrite it. Like for example, where you had a 0 or 1, put an X, blank maybe. No, it can't be a blank. Maybe you put an X. So that means you could put it. You could put an X. That would be a member of your alphabet. Your tape alphabet. No, a bit fuzzy on that. Anyway, we'll get to that. Okay. So you've now crossed out. You put an X on the first symbol here and the first symbol here, and then well, there's different ways of doing it. But then you could come right back here until you meet your X. You just read back until you meet your X, and then you move one to the right, and you look at the second symbol, and recall what it is. Is it a 0 or 1? And then move all the way back again, until you come to the X, and then you move 1 to the right, and then look at the second symbol in this string, and is it a 0 or 1? If the second symbol here and the second symbol here are different, then reject. Go immediately into a reject state and stop. Okay? If they're the same, and well, you can see where I'm going. Okay? Until eventually you've got all X's in this string, and you've got all X's in this string, and then you check for the next one to the right, because it's possible the string here might be longer than this one. That's a possibility, so you need to check for that. So you've got all these are X's, all these are X's, an equal number, and then you move to the next symbol. Now, if it's a blank, that means you've found that your string is of this form. If it's a blank, then you go immediately into accept state and stop. So your machine, your TM, has been successful in showing that the input string is of this form. Now, if it's not a blank, if it's something else, 0 or 1, well, that means the second W here is longer than the first one. Like, this substring is longer than this substring. So in that case, these two are not the same. They're not the same W. They're not the same substring. In that case, that's a failure, and hence the machine would go immediately into reject state and stop. Okay? Alright. I think I've said in words a lot of the next session, but okay, I'll stop here.